first of all, before you get into this, you got to understand what does probability stand for, or what does probability mean? What is probability of an event? What does that mean? Chances, okay? So when you talk about this thing called probability of an event, you guys ever seen anything written like that before? What they do a lot of times when we talk about this thing called probability, they use a capital letter P, and they put something in parentheses of what you want to happen. For example, what's the probability that I roll a 3 on a die? On a single one die, what's the probability I roll a 3? 1 out of 6. So what you're doing is you're already giving me the probability that something occurs. The 1 out of 6. You know what the numerator and the denominator stand for in this case? You're on the right track. The numerator is basically ways, it's how the event can happen, or it's the favorable, we'll do this, over total outcome. It's your favorable outcome over total outcomes. So if you start thinking about rolling a die, if you have a 6-sided die, there's only 6 possible things that can happen. A 3 is one of them. What's the probability that I can roll an even number? 3 out of 6, because there's 3 even numbers out of 6 possible. And what do you always do with your fractions then? Yeah, so your probability of rolling an even would be 1/2. Okay. Now, with probabilities, the probability of some event occurring, your probability is always going to be less than or equal to 1, but greater than or equal to 0. Probabilities are never greater than 1, and they're never negative. So if you think about it, the probability, if you get a probability of 1, like, what's the probability I get an even or an odd on a die? 1. 6. There's 6 total. There's 3 evens, 3 odds, and if I roll the die, that means it happened. I got an even or an odd. So the probability of that occurring is 1, which means it happened. So if you get a probability of 1, it's going to happen. Okay, it's a more likely occurrence. The probability of 0 then would be not going to happen. So what's the probability I roll an 8 on a single-sided die? 0, because there's no 8 on a single-sided die. What's that? Oh, I'm sorry, with a single die. Yeah, with rolling a single die of 1 through 6. Sorry. I meant 6-sided die, not single-sided die. Yeah. There's that whole 4th dimension thing where it turns inside itself. Yeah. Thinks I went this way, he went that way. He's just laughing at me. He said, "Where did you go?" He said, "Where did you go?" Anyway, so you have probabilities will always be between 0 and 1. So if you get a probability that's negative, you screwed up. Fix it. If you get a probability bigger than 1, you also screwed up. You'll need to fix it. Oh, Bella, how'd you do? The nickel? Does that mean like 5th place? Bronze? I was joking because I was thinking of the place. Well, we missed you, and Miss Ford realized something, and she doesn't want to say it out loud, but I can help her if she wants. Sure? No, she said she learned more in those 2 days without you there. It was awesome, she said. And she said she wants to move her seat. I'm messing with her. It's a good time. Good conversation. I know I should, right? So when we get into the idea of what's called geometric probability, we're going to look at stuff. Bless you. We're going to look at shapes. Find a probability that a point lies within a shaded region. This is what it's going to look like. So let's say you have a rectangle that's 6 by 12 and the interior is 3 by 8. And what we're going to do here is we're going to talk about probability of shaded region. Shaded region problems haven't changed. You all know how to do shaded region. The only thing that's going to be different here is how you set it up when you're done. So in order to find what's called probability of a shaded region, it's nothing more than the area of the favorable divided by the total area. And again, this isn't anything that's going to be all that difficult. Right? It's actually easy. Remember, I will give you formula sheets, so you don't have to memorize formulas and whatnot. If I'm looking at the area of a rectangle, how do you find the area of a rectangle? Base times height, length times width, however you want to say it. In this favorable region here, the shaded region in this case, it's created from a rectangle, and what was cut out of it? A rectangle. Okay. So what you have to do is first find that shaded region. Well, to get the shaded region, you have your 6 by 12, and to that you got to subtract 3 by 8. And what they say when I write it out as the denominator of the total area, I'm talking about the largest shape you have there. So the biggest shape you have is the what? The rectangle, the 6 by 12 rectangle. Okay. So once you get to this, it's nothing more than just really getting your calculator out, creating a fraction mark. 6 times 12, subtract 3 by 8. Oops. Oh, so I hit the button 3. Over a 6 by 12. And the idea here is that you have to have a fraction mark to make this stuff work. Right? And then enter. It does the work for you. These calculators simplify the fractions for you and do all that stuff. Okay? And obviously, my fraction here is 2/3. 2/3 is less than a whole. The probability of picking a point at random in that shaded region would be 2 out of 3. Okay? It really isn't going to be all that difficult. You're going to see a lot of different areas, a lot of different shapes and things with the formulas and stuff that you know. And quite literally, it's adding one step to finding the area of a shaded region. All you have to do at the very end then is divide it by the larger of the shapes. You go on to the next problem. Right. Not terrible? Usually isn't. I keep forgetting to change the color of this. Closest I can see that. So if I look at something like this, on my computer they look fine, but I always forget that when the lights are on, it's a little bit more difficult to show. So if I'm looking at this, I want to find the probability of landing in the circle. If I want to find the probability of landing in the circle, well, we have a circle inside of a what? Square. Okay? Which means, what's the area, or what's the favorable region's shape? Circle. And what's the biggest shape? Square. So in this case, I just have to find the area of the circle and divide it by the area of a square. Whereas it could be asked differently, I could say, what's the probability that I land inside the square, but outside the circle? You can see how that would be different. You have to subtract out the circle. So it's a matter of reading carefully as to what it's asking you. The math is easy. It's just writing it out. 12 represents what of the circle? Good. If it's the diameter, what's the radius? Good. So you have a radius of 6. What's your area of the circle? Excellent. So the area of my circle would be 36 pi. To that, I have to divide it by 144. Good. Then 12 by 12. If I throw that in my calculator then, and you simplify it out, I believe it just says pi over 4, right? What's that? Am Am I right? And then it comes out as pi over 4?
Yeah.
Okay, what's the decimal of that? Remember how to hit the button? What was it, 7/8? 7/9? There you go. Decimals or fractions, as long as it's less than 1 and greater than 0, we're good. Okay? As long as it's less than 0, greater than 1, we're good. Again, it's pretty darn simple. Not terrible. Well, let's see how fancy we can make this. I'm sorry, what's that? Oh, our circle has a radius of 6. I didn't write, I should have written it. So you have the area of a circle, and you have to divide it by the area of a square. And we just said it real quick. Sometimes you get dartboards. I think we defined this last week. Remember when we had circles that share a common center? What were those called again? Concentric circles. Those would be called concentric circles. Okay. Circles that have the same center are concentric circles. And if you look at it, this was one of the things, I think it came up last week where we had a problem where it kept showing little segment pieces. You had to kind of add them together to figure out how, like, different radii and whatnot. Same thing goes for here. Because if you think, you've got 1, 2, 3, 4, 5, you have 6 circles. Each of them has its own radius. First one has a radius of 3. The next one has a radius of then. Easy. The idea of going back and forth on it. Now, let's say I wanted to find the problem. What would the probability be that I hit a bullseye? What's that? Why is it 1/4? Mm-hmm. Now you're talking segment though, are you? But I'm talking areas. What do you do with areas though? Well, write it down. You're on the right track. You're on the right track. Write it out. Because if you're going through it that way, if I want to go bullseye, what's the radius of the small circle, of the interior circle, the center? 3. So then you're right. So now your area would be 9 pi. And you said a second ago that the other one had radius of, what was it, 12? That's where things get different. The difference between linear and area, you got to watch out with your values. You weren't wrong in thinking, if you were talking segment-wise, that first 3, if I was going to land on that segment, you're right. It's 3 out of the 12. When I get into the area, you got to change the dimension. You go into that second dimension. So if you throw that in your calculator, what do you get? What is it? 116. Now, remember, what do you have to do with your calculator if you've got pi in the numerator and denominator? What do you have to use? You got to use a fraction bar. Okay? Remember, you got to use a fraction bar here because if you don't, watch what happens. But if I do 9 pi divided by 12 pi, I'm pretty sure that I don't want a probability of 7.4. That means I'm doing something wrong by a lot. That's why we only use the fraction bar. When you're dealing with probabilities, do I have to worry about units? No, I don't. Because if you think about it, what was the area? This would be 9 pi units squared. That would be 144 pi units squared. Units squared divided by units squared, those units themselves simplify out. All right, what's the probability that I land in this circle? Just that secondary orange ring. What would the probability be if I land in that secondary orange ring? What would you do? on the area of that ring, right? Yes, ma'am. Yep. Yep. What you're doing here, guys, is you're talking about shaded region. As you get into shaded region, that's all you're doing. You're looking to figure out what you have to back out in order to make stuff work. Well, I missed.
What's the problem? Not very good.
Hey,
Can I do it?
You really think I'm
That's what I was thinking.
I can't break the smart board.
Can I do it?
Well, these are the
How much was that cost?
this
Smartboard or
smart board. These are they're $3-4 grand a pop, I think. They're not cheap. But no, you can't. It's really hard to break these. You ever notice there's a little like a dent right here? If you look, come here. If you look up here, you can see there's a little dent right. You can feel it. I hit it. You can. It's not gonna do anything to it.
Yeah.
It doesn't do anything to it.
Okay.
No, I already did. There's a dent in it.
That's not real. That's
So-
not our class though.
This is the second version of the smart boards that we've had in the district. The first ones that were down over at Huntley before we moved here. If you make a fist or just hold your hand like that, you know how you can push on the meat of your thumb, if you will. So the old smart boards had like a pressure part to it. It felt like that. If you make a good cleanse fish and you kind of can press on it a little bit. So the old smart boards were like that. It would sense where you were because of the pressure you're putting on it. It was almost, these were almost kind of like it's like a mat, like the heavy duty floor mats you stand on, just like the people like Judkins has because his feet hurt. It's like one of those things. Whereas the newer style that we have here, if you've ever noticed in the four corners there's these little light sensors, and those light sensors are figuring out where you are in essence to everything here. So it picks up your hand movement. The old smart board being basically a pressure plate to it, these things work great because I could shoot at it all day long and it would go off. This one, it doesn't necessarily work all the time because it doesn't need that pressure of it touching it. It needs to have something sense that it's been touched. This hits the smart board too fast.
Wait, how long did you do it? I remember in 5th grade we just had them.
Well, we've had them for, let's see, I've been teaching for about 13 years, so we've had them for at least 10. We've had smart boards for about 10 years. 19 years, something like that.
Hey, I remember. This time.
Hey, you know what? This isn't real high quality stuff here. So I'm trying to shoot with like a $2 bow and arrow.
See if you
Oh, it's there too.
That's a bullseye.
Yeah, because I need it. I need all the help I can. All right,
Oh,
one more.
it wasn't like.
Dartboard.
Wait, really?
Yeah.
No.
Yeah. You know the smart boards can make sound effects?
Yeah.
Oh, yeah.
Do it again.
Oh, I like that around here.
Yeah, okay.
Let's just say I'm more of a purchaser than a hunter. I'm trying not to let children use this. Fun. All right, I'm going to use a good crossbow.
Oh.
Does everyone put an apple on their head and stand up there?
Are you so ready?
No. No. More of a joke. I really don't want to shoot me in the head. Or do a lot. At least I got it. At least I got one. There's supposed to be sound effects off, but it doesn't. Why is this working today?
Oh.
This is something. You know, that's the thing. It doesn't sense it, but the newer board doesn't do a great job with it. Finger on it. It moved me. That was the last one. I'm fine. Why do you ask? Yeah. You know how easy it is?
Make another one.
To make these things, it's really
Make
easy.
another one.
You all have to do is import sound. I didn't know how to do this. I didn't do it. That was Friday.
I did.
That was the assignment.
I did today.
Yeah. That was the assignment that I sent on Friday. Anyway, so what we're looking at here then is I want to be able to do stuff like this. Find the probability of landing in shape. Where you've got shapes, you've got dimensions, you want to figure out, well, how do you land in the shaded region? Well, with most of these things, it's just a matter of, again, find the area of the shaded region and then divide it by the total area. What I mean by total area is what's the area of the largest shape. Okay. A second ago, when we were doing the concentric circle stuff, I kind of got a little sidetracked with the awesomeness of the bow and arrow. If you're looking for a concentric circle, if you had to find just that one singular ring, you had to find the area of that whole circle, and then we would have backed out that middle part. So I think that one had an overall radius of 6, and we had 36 pi. You had to subtract out the 4, I want to say. So you wind up with like a 20 pi for that, and then you divide that out by the whole 144. It's nothing more than you haven't done. The only thing that's new today, really, is just adding that one last step of dividing out by your total area. So here you've got a trapezoid with a rectangle cut out of it. And you can do one of two things with this. The two side pieces create, if you put them together, what do they create? They create a triangle. Very good, okay? So if I'm looking at this, my shaded region, if this is 14, how much is left for here and here? On both sides, correct? So that gives you a base of a triangle of 6, correct? So I have a 1/2 6 by 12 for that triangle shaded region area. And then I'd have to divide that by the entire shape, which is a trapezoid. Now, trapezoids were what? 1/2 the height times the sum of the bases. Just a matter of putting it together. 1/2 the height, sum of the bases. And again, I can't stress this enough. Try not to do it all at once because you'll screw something up. But just solve them separately and then divide it out. What's half of 12?
6.
What's 6 times 6?
36.
All right, so you have 36 for the numerator. 20 plus 14 is how much? 34. Half of 12 is 6. So we have to do 34 times 6. Press a button in the calculator. What do you get? 34 times 6? You get 3/17 when you're done. The calculator does the work for you. You just have to press the buttons correctly. 3/17 is obviously it's smaller than a whole and it's larger than a 0. So that usually means you're on the right track. Okay. Not terrible, is it?
No.
It usually isn't. It usually isn't.